So now that we have an arraying system of trusses with stringers attached, and that works very nicely, and we can adjust the diameter of the cords and stringers, and I'll make them a little smaller for visualization's sake. And we can change the length. Everything is completely flexible. The depth, our catenary can do everything that we want. And I'm going to also extend the array a little bit, maybe add a few more bays to this. We're going to now add the rotation function so that you can see, starting from the first truss as a level horizontal element, adding an incremental rotation of a number of degrees as we go. That will be useful for you to make even a simple kind of curving or sweeping roof. There are other ways that you can induce curvature to this, perhaps by using importing geometry and arraying along a curve, etc. But here we're building everything from scratch with no input geometry. So working from our array of trusses, we're going to create the rotation, and I'll start with the rotate component. And the one that we want is rotated in a plane. Now the first one that comes up. So it wants a plane, and we can provide that pretty easily. We can give it an XY plane or a YZ plane. In this case, we want a YZ plane, i.e. the vertical plane. And we can put that in as the plane for our rotation. You see it showing up here on the left as a construction plane. And this is how we use construction planes in Grasshopper. So now we need to tell it the angle that we want it to go through, and we want to feed in the geometry. The geometry will be the top chord that right now is going through the array function. We're going to let it keep going through the array function, but then before we pass it along to this curve bucket, we're going to take it and put it through a rotation cycle. Understanding that you could always disconnect these and allow it to be simply a straight array rather than a rotated array. So these build upon each other, but they are not exclusive of one another. You could connect and disconnect, which is the reason why we put this curve bucket here, so that we could connect things differently through this set of functions that we're adding. For the rotate, we want to give it a series of angles, and we're going to control those with a slider. So we could just copy a slider, rename it, and start to use it. But we have to use it with some other components in order to convert this into the angles that it wants. Because if you look at and hover over the input for the A on the rotate, it wants a value, a rotation angle in radians, not in degrees. And I don't know about you, but I don't really speak radians very well. So we're going to have it work in degrees. I'll take this and I'll edit the slider, and I'll tell it that we want to go from 0 to something less than 10. You don't want to go more than 10 degrees per truss, because by the time you get to the 9th truss, you're at 90 degrees. This rotation is not a cumulative rotation, it's an aggregate, and it aggregates with this number of degrees each time. So 5 is probably the most you'd want to do for each, and I can also rename this as angle. But now we need to take this and convert it to radians, because that's the data that the rotate component is looking for, or the form of the data. To do that, we're going to use a number component. And this number component allows you to not just collect a number or a series of numbers, but to change its value. So if we take this number component and right-click on it and go down to Expression and then move to the right and click on Expression Editor, you'll see this Expression Designer window come up where there are a whole list of operators and constants and functions, mathematical functions, many of which are way beyond my comprehension. If we click in the upper right, you'll get a list of the functions, and you'll see the one we're looking for if you scroll down, and you'll find rad, and the way that it's written is rad parentheses x close parentheses converts an angle in degrees to radians, and that's the one that we want. So we know what it is now. We can't just click on it. We have to type the expression rad open parentheses x close parentheses. No syntax errors, so we say OK. We have now set that expression into this number component, and we now need to create a series, because this is not just going to work for one number at a time for the rotation, but we want to rotate each one of these in turn, each one of these trusses. So we're going to create a series. Double click and just type in series, and you'll get the series component. And for that, we want to put in a number and a number of steps, right? So the series, the n for the series is the step size, which is our angle, right? Each step will be 5 or 4 or 3 degrees. So that's our step size, goes in there. And then below that in C, it wants the number of values in the series, and that's going to be the same as the number of trusses, and it will change as we adjust our array. So I'll take this and connect that slider from the number in the array, right? And so my series now contains 8 values. If I move my slider down to a lower number of 4, now my series up above contains 4 numbers, and each one, as you can see, goes 3.93, and then it doubles that, and then adds it again. So it keeps adding 3.93 to each of these positions in the series, and that's exactly what we wanted to do. Let's put it up to 5, hover over it, and you see our series of 4 numbers goes from 0 to 5 to 10 to 15. So that's what a series is, and as we increase our number of trusses, our series will grow up to 40 degrees. So that's our rotation angle as a series. We're now going to take that, plug it into the number component, so it's converting degrees to radians, plug that into the rotate, and now all the rotate needs is geometry. And the geometry will be the trusses. So we will take the array of trusses, bring those up here as the geometry, feed those in, and if you look at the window on the left, now you see a series of top chord lines, curves, that are angling up, and I can move them down. I can make this sort of wave up and down. And now I need to take the output of that and substitute it for the simple array into this curve bucket down here highlighted in green, so that now the top chords are the ones that are arraying and rotating, not just arraying, are the ones flowing through this curve bucket onto everywhere else that they need to go. You'll see in the visualization here on the left that the original top chords underneath are visible as lines or curves, and I'll zoom in here in a minute so that you can see those. There's a series of horizontal top chords under there, but the overall system now is following the rotation that we've asked it to do. I'll reduce the number a bit and maybe increase the rotation angle so that you see it going up and down. It does go from 0, meaning flat, so we can have just a regular flat array or something that grows by a certain angle increment in series as it proceeds. I can take the array of top chords that are here and I can turn off the preview of those so we only see the new trusses. And similarly, later I can also take all of these points, the little X's, and I can turn off the preview for those just to see the geometry that we want. But now we have the rotation working very cleanly, and so I'll move my components around a little bit, and I'll group them. And I will give a name to these, and I'll call them rotate. I'll borrow array, put it up there, make that say rotate, and make that part of the group. And the rotation is now working very smoothly. So I'll stop here. The next video is going to begin by creating some more useful geometry that you can put to work once you've baked this into Rhino so that you can create a wall for this to sit on, or beams to carry the end of these trusses, and column systems, which could be done in Grasshopper, but for the sake of simplicity, I want to keep this as a truss and truss system creation exercise, and then have you go ahead and build supporting walls or columns and beams in Rhino, but having geometry that you can use that will be helpful for you to build that so that it aligns with the ends of the trusses and the system that they create. Thank you.